In 1960, three scientists proposed an idea that would flip the world of ecology on its head. Their names were Nelson Hairston, Frederick Smith, and Lawrence Slobodkin, and their idea was known as the Green World Hypothesis. This hypothesis, like the name implies, attempts to explain why the world is green, why the world has so much vegetation. The best way to understand why the Green World Hypothesis was so revolutionary is to think back to your high school biology class. When you learned about ecology, you probably learned about this, the food pyramid. You've got producers at the bottom, primary consumers then eat the producers, secondary consumers eat the primary consumers, tertiary consumers eat the secondary consumers, and so on. Each section on the pyramid is what's known as a trophic level, and the amount of energy available in each trophic level decreases as you go up the pyramid. That's because when you eat something, you don't convert all of the energy in that food into energy for yourself. Eating is inefficient. So when you look at an entire ecosystem, plants have the most energy since they make food through photosynthesis. Herbivores then eat those plants and get some of their energy, but not all. Smaller carnivores then eat those herbivores and get some of their energy, but again, not all. By the time you get to the top of the food chain, the amount of energy available for consumption is extremely limited, which is why large predators aren't typically as abundant as, say, herbivores or plants. There simply isn't enough energy in the system to support them. This entire system of relationships is driven through what are known as bottom-up processes. In other words, the amount of resources at the bottom of the pyramid, things like food and habitat, ultimately determines what happens at the top of the pyramid, like how many large predators can be supported. This bottom-up approach is one of the main tenets of ecology. Or it was, until the Green World Hypothesis came along. Because the Green World Hypothesis argues in favor of a top-down approach to population dynamics. Hairston, Smith, and Slobodkin argued that it was actually large predators at the top of the food chain who influenced the ecosystem all the way down to the bottom. By eating herbivores, they said, carnivores actually protected the plants at the bottom of the food chain from being eaten. Thus, the world was green because carnivores prevented all of the vegetation from being eaten. This turned one of the foundations of ecological theory upside down, literally. And as you can imagine, ecological researchers were skeptical. They argued that ecosystems were too complex for such a simple idea, or that chemical defenses were the main reason plants weren't eaten by herbivores. But as the years have worn on, more and more studies have come out in defense of the Green World Hypothesis, not as a be-all, end-all ecological theory, but as a sort of complement to what we already know. Of course, nutrients and resources and habitat play a key role in how ecosystems operate, but more and more evidence points to the undeniable fact that predators also play a key role in our ecosystems. And this, finally, is where our national parks come in. Because as we've learned more about predators, we've learned that they're disappearing. Their habitats are shrinking, which means their influence over those habitats is also shrinking. This makes our national parks and protected areas more important than ever, as they're some of the last places where large predators roam free, where they're able to influence habitats we now know they are so vital to sustaining. And so, over the course of my next 3 videos, I'm going to bring you 3 stories of predators in our national parks, and the roles they've played in shaping some of our last remaining wild places. To start off, we head to Isle Royale National Park, home to one of the most famous and longest-running predator-prey studies in the world. That study focuses on moose and wolves, and has been running continuously on Isle Royale since 1958, 2 years before the Green World Hypothesis was even proposed. And it's the longevity of this study that has provided us with such critical insights into the nature of predator-prey relationships. Typically, ecological studies will take place over a few years, and while they still yield important results, studying a single ecosystem over several decades really allows us to understand its population dynamics in a way other studies simply aren't able to do. Here's what we've learned. It's believed moose first arrived on Isle Royale at the turn of the 20th century, although we are yet to figure out why or how. Wolves then followed 50 years later by way of an ice bridge from the mainland. That ice bridge is important and we'll come back to it, but first let's talk about how Isle Royale's moose and wolves interact with one another. Wolves are the only apex predators here, and moose are, obviously, their prey. Now, the moose, even though they're prey, are much more abundant on the island than the wolves, even when their population numbers are low. If you think back to our ecology lesson, moose are herbivores, and so there is much more energy in the ecosystem for them to consume than for the carnivorous wolves. And that's okay, because there are enough moose on the island to sustain the wolf population. But what's really interesting here is the way these two populations fluctuate. Because we've been studying this ecosystem for so long, we have a really good idea of how many wolves and moose are on the island in any given year, and we can record long-term trends for each of them. Over the last several decades, researchers have found that when wolf populations are high, moose populations are relatively low. When wolf populations are low, moose populations are relatively high. It seems as if Isle Royale's wolf population is directly influencing the behavior and abundance of its moose population. That may seem relatively straightforward, but it isn't all that researchers have found. Remember, the green world hypothesis says that carnivores can have a direct impact on the lower levels of the food chain simply by controlling herbivore populations. Take balsam fir, one of the main sources of food for moose during the winter. Researchers found that when wolf populations were high, balsam fir actually grew more than when the wolf populations were low. The theory went that by keeping the moose population in check, wolves were allowing balsam fir to grow more. And when you think about this for all of the other vegetation moose might eat, you can begin to see how big of an impact the moose might have on Isle Royale's plant communities. Vegetation that they don't eat provides food and habitat for all of the island's other plants and animals. Essentially, by killing and eating moose, the wolves are keeping this whole system balanced. And here is where we double back to the ice bridge. Now, this may come as a surprise, but Isle Royale is an island. And because it's an island, the terrestrial animals that are there can't leave. Likewise, animals from the mainland can't come to Isle Royale. If an animal population is big enough, this isn't really an issue because there is enough genetic diversity in the population to prevent inbreeding. This is the case with many of Isle Royale's isolated animals, including its moose. But for wolves, it's a different story. There simply aren't enough individuals on the island to support a genetically diverse population. And so the ice bridge was crucial to introducing new individuals and new genes into the population. Because of the ice bridge, Isle Royale's wolves could stay healthy and diverse. But over the last few years, that ice bridge has formed less and less, and climate change is the primary culprit. Warming temperatures from runaway greenhouse gas emissions have caused less lake ice to form, making it increasingly difficult for wolves to travel between Isle Royale and the mainland. The wolves no longer have that vital genetic link to the mainland, and inbreeding has started to decimate the population. By 2018, only 2 wolves remained on Isle Royale. With the decline of the wolf population, the moose population has exploded, and given what we know about the role of wolves in balancing this ecosystem, their loss could have severe consequences for Isle Royale's fragile ecosystem. Luckily though, in 2018, the National Park Service made the decision to reintroduce wolves to Isle Royale National Park in an effort to restore what many see as balance to this fragile ecosystem. 19 wolves were reintroduced, of which between 12 and 14 still remain on the island. Isle Royale's wolf population, maintained for generations by an ice bridge, is now dependent on humans in the form of an air bridge. But regardless of how wolves got to Isle Royale, or how they will continue to get there in the future, a few things are certain. That wolves play a key role in this ecosystem, and that protected places like Isle Royale help maintain that role by keeping wild places wild. And as always, if you want to learn more about the world's protected places, don't forget to like this video and subscribe to the channel. Thank you so much for watching. Goodbye.